This lesson is on Newton's second law. His second law states that if an unbalanced force acts on a body, it will accelerate in the direction of the net force. The acceleration is directly proportional to the net force. And we have an equation that we can use to represent this law. And that's this one here. So net force is equal to mass times acceleration. And you can see that the net force and acceleration are both vectors, and therefore they're in the same direction. And if you want to see the justification for the equation here, you can check out page 131 in our textbook. So I'll just do a little quick example here showing you the acceleration and net force. So let's draw a little free body diagram here. So there's a block sitting on the ground, so it must have gravity acting on it, and since it's on the ground it must have normal force, and these forces must be equal, so there's no unbalanced force there. But if it's accelerating to the right, that must mean there is some kind of applied force acting on it. So in this case, F net would be equal to Fa and would be equal to mass times acceleration. So your applied force would be equal to mass times the acceleration of the object. We'll do a couple of examples. So the first one here, a block of mass 10 kilograms is being pushed along a frictionless surface with a force of 30 newtons. What is the acceleration of the object? So I've listed out our given and required, and we should draw ourselves a free body diagram. You can also draw a system diagram, but the only one that will be required of you is the free body diagram. So if you're comfortable with just drawing that, then that is fine. So this free body diagram should look a lot like the one on the previous slide. It's sitting on a surface. We're assuming it's on Earth, so we should have normal and gravitational force, and we know they are going to be equal. And we also have an applied force that's given in the question. So it seems pretty clear to us it's going to accelerate this way. So if we look at the analysis a little bit here, we need to consider F net. And you should recall from previous lessons that F net is the sum of the forces. So we have gravitational force, and normal force, and the applied force. And remember to think too of F net having an x and y. So x, right, is Fa, and y is g plus n. And we know that they are equal and opposite, so this ends up being 0. So we're just left with the applied force, and we also know that F net equals ma, so this also means that mass times acceleration is the applied force, and we're going to look to solve for acceleration. So we have the applied force divided by the mass. If we plug in some numbers, acceleration is 30 newtons divided by 10 kilograms, which is 3 newtons per kilogram. And if you expand out the units, remember newtons is kilograms times meters per second squared. So what we're left with here is meters per second squared, which is what we should have because we are looking for an acceleration. So I can answer the question now. Therefore, the acceleration of the object is 3 meters per second squared, and we'll say to the right. And we'll do one more example. Example 2 is a falling object is 5 kilograms and experiences 20 newtons of resistance. What is the acceleration of the object? Okay, so this time we have a falling object, so it still must have gravity acting on it. And we're told in the question that there's a resistance force, and resistance always opposes motion, right? And we've kind of already established that the motion is downwards, so it must be accelerating downwards since it's falling. So we have here that F net is the force of gravity plus the force of the resistance. And I'm going to add also to this diagram here that the acceleration downwards is also going to be our positive direction. Yeah, so I'm just going to nicely rewrite this as Fg minus the magnitude of Fr, since Fr is upwards. And we also know from previous that force of gravity is mass times acceleration due to gravity. So F net is mass times acceleration due to gravity minus Fr. And F net is also mass times acceleration. And we're looking to solve for acceleration, so we need to divide by the mass. So this tells us that acceleration is 5 kilograms times 9.8 meters per second squared minus 20 newtons over 5 kilograms. And the 5 times 9.8 at the top there gives us kilograms times meters per second squared, which we know is newtons. So when I pull up my calculator and I type in 5 times 9.8, I get 49. So 49 newtons minus 20 newtons. Remember, to add and subtract, it has to be the same unit. So this is 29 newtons divided by 5 kilograms, and on the previous slide, newtons divided by kilograms gives me meters per second squared. So we've got 29 divided by, I'll be able to type into my calculator here, 29 divided by 5 gives me 5.8 meters per second squared. That's my acceleration. So now I can answer the question. Therefore, the object accelerates downward at 6 meters per second squared. I'm just going to round it there. And there we have it.